this problem, we're going to calculate how much time it takes to discharge a capacitor with a 260 microfarad capacitance through a 500 ohm resistor down to 10% of its original voltage. My printer is talking to me. So the first thing that we're going to do is figure out the time constant. We're going to need that for this problem. And that's going to be 500 ohms times 260 times 10 to the minus 6 farads, which yields 0.13 seconds. Right? Remember that this is R and C. Now the reason that we want to calculate tau is that if we look at the delta V for a capacitor as it's discharging, right, this is a little different than when it's charging up. As it's discharging, it's going to be its original voltage, which is usually set by the battery, but we don't have that information here. But we do know it's an exponential decay. And so it's an exponential decline with time from that original voltage. And that the steepness of that exponential is set by our time constant. Now, we also have this 10% of its original voltage. Well, what is 10%? 10%, I like to think of it as 10 over 100, which would be the same as 1 over 10. Right? It's a tenth of our original voltage. Right? That's also 0.01. Now, there's many different ways of approaching this, but one way that is kind of nice mathematically for this problem is to write down 10% as 1 over 10 V naught. Right? That is the potential that we're looking for this capacitor, and we're actually looking for T. That's our unknown, but I know that it's a tenth of the original value, which is also on the left-hand side of the equation. And so now we have these two terms, canceling. And so that's going to be a 1 over 10 is equal to e to the minus t over tau. Now, there's a little bit of a mathematical trick here, which is to divide both sides by this term. And when I do that, I'm going to end up with the following expression. E to the t over tau is equal to 10. Essentially, it's a cross multiplication, if you want to think of it that way. But when we end up with the negative, right, so we would end up with something like 1 over e to the minus t over tau is equal to 10. Well, that negative here allows me to bring it up to the top and make it a positive because it was in the denominator. And so now we're going to take the natural log of both sides. And so this is going to be t over tau is equal to the natural log of 10. Right? Both sides have to be unitless. Whenever you're dealing with logs, you should have unitless expressions. And t then is equal to our time constant times the natural log of 10. And so this is going to be 0.13 times seconds times 2.3 unitless, and that yields 0.299 seconds. So you'll definitely want to get familiar with having to use natural logs with these exponential expressions. Thanks.